Hello everyone, welcome to Tech with Machines. Our today's topic is distributed locking, one of the most important concepts in microservices and system design. I'll try to explain it simply with real examples, and hopefully it should be able to explain you that how to prevent race conditions in this distributed system and what is actually distributed locking. Now let's start with the problem. Assume there are multiple services which are running at the same time and all of them are trying to update the same data, like a customer placing an order through two different systems and the order gets placed twice, or a customer trying to pay for a product but the request reaches two different servers and they debit the price twice. So it will lead to data inconsistency, or it will lead to duplicate processing. Now, how can we handle it using a normal lock like synchronized or mutex? No, because such locks work only inside your application container. In a distributed system, different services don't share memory. So they don't even know that there is a lock acquired. So in reality, how the distributed systems work, there are multiple instances of the same service deployed across different machines and they can fail independently. So concurrency issues are very common. Now, what is distributed locking? Distributed locking solves exact problem of concurrency, and it ensures that only one service instance across all machines can access a shared resource at a time. Everyone else has to either wait or fail. Now, how it works at high level? At a high level, it has three simple steps. First, a service tries to acquire a lock. Second, it executes the critical section. And finally, it releases a lock so others can proceed. Now, the most fundamental question will be, where does this lock get stored? The key idea is that lock is stored outside of the service. The external system is shared by all instances, common choices being Redis, Zookeeper, or database. The most common and practical choice has been Redis. It's fast, it's in memory, and it's already used in most backend systems. Now let's break down this Redis command which you are seeing on the screen. This is the heart of the lock. NX means the key should be set only if it doesn't already exist. PX adds an expiry time, and the UUID uniquely identifies the lock owner. Now, why lock expiry is critical? Now, what if the service crashes after acquiring the lock? If there is no expiry, the lock will live forever and block the system. That's why TTL or expiry is absolutely critical in distributed locking. How do we do safe unlocking? Releasing the lock also needs to be done carefully. A service should release the lock only if it owns it. That's why we compare the UUID before deleting the lock, usually using a Lua script in Redis. Now, common mistakes which are made in distributed locking. Databases can provide or might not set expiry, or we might set a long TTL, or we might delete locks blindly, or we might use locks everywhere. Distributed locks are powerful, but they must be used carefully. Now, what are the other locking options? Redis is not the only option. As I said, databases can also provide locks using transactions. Zookeeper also provides very strong consistency guarantees. The choice depends on performance and consistency needs. Now, when not to use locks? It's also important to know when not to use them. If idempotency, optimistic locking, or event ordering can solve the problem, they're often better and more scalable. Because locks can introduce bottlenecks. It also introduces the performance delays. So what is the key takeaway in this? The final thought I would say is that distributed locks trade performance for correctness. Use them only when correctness really matters. If this video helped you, like, subscribe, and I will see you in the next one. Thank you.